Now let's turn our attention to another set of data structures, matrices and arrays. The characteristics of a matrix is that it's a two-dimensional atomic object, that is, all the same data type. You can think of a matrix, in fact, literally it is, a vector of vectors. So we talk about R being a vector language. We haven't left that when we go to matrices. We're now creating a vector of vectors. The class of a matrix is matrix, and the default attribute is dimensions. That is, the number of rows and the number of columns. Let's look at how we create a matrix. A matrix is created by creating a vector, but specifying that we want rows and columns. That is, we provide R, a vector, and two dimensions. The first thing we can do is use the matrix function to create a matrix. Here I've done so, putting in a vector and then specifying I want 3 rows, 4 columns, and here's my matrix. Now notice that when we entered 15, 22, and 25, that it went into the column first and then went to the next column for 9, 14, and 14, and so on. The class is matrix, and the attributes are dimensions, in this case, 3 rows, 4 columns. When we enter data with the matrix function, if we leave off one dimension, the other will be inferred. Here I've asked for 3 rows. It gives me 3 rows, 4 columns. It figures that out from the length of the vector that we've supplied to the matrix function. Here I'm doing the opposite, giving it 4 columns, and we still get the same thing. We can switch the order of entry by setting by row to true. If we don't use by row, it is assumed false. So that's why before you saw that the entry was by column. Here I'm going to do it again, but this time enter it in by row, and now the 15, 22, 25, and 9 are on the first row. A matrix can be created by binding columns. So here I'm creating 4 vectors. I'm going to call them column 1, 2, 3, and 4. Then I'm going to bind them with this function here, cbind, which stands for column bind. And here's the matrix. Or we could bind rows. So let me create 3 more vectors, call them row 1, row 2, row 3, and we use the, you guessed it, rbind, standing for row bind. A matrix can also be created by giving a vector dimensions. So here is a matrix that right now is not really a matrix, it's just a vector. But if we tell it that we want 3 rows and 4 columns, it will do that. Rows and columns can be named at the creation of a matrix. We do this using the dim names argument to our matrix command and putting these in a list. We have a list of 2 vectors, one for the row names, one for the column names. So here I've named the rows, row 1, 2, and 3, and the columns, column 1, 2, 3, and 4. You can also do this after the matrix is created using the row names and column names functions. So here is a matrix. I'm going to set the row names, the column names, and the same result that I got before. If I want, I can dispense with the names by setting the row names to null and setting the column names to null if I want to dispense with those as well. Row and column names can be added all at once with dim names, just as we did when creating the matrix. So here we have my matrix doesn't have names anymore, but I'm going to put them back. And I'm going to use dim names for my matrix. And again, we're going to use a list that contains two vectors. We can use dim names to set the row and column names both to null all at the same time. So creating a matrix. We use the matrix function. We can indicate one or both dimensions. The default data entry is by column. We use the cbind or rbind function. We use dim to give dimensions to a vector. And names can be added before or after matrix creation. We can use dim names for both dimensions or row names and column names to give one dimension at a time those names. Now let's talk about subsetting or extracting from a matrix. We can create a subset of a matrix, that is, extract elements of a matrix, by extending vector extract operations to be two-dimensional. And here's the key. We still use the square brackets, just like we did with a vector, but now we use a row-column format. So, remember here in our console, we have my matrix. This first command on line 144, my matrix, we're going to use the extract operators or subset operators to extract from the second row, third column. That is the number 27. Look up at your matrix, second row, third column. That's it. If you want to select multiple elements, you can do so. All you have to do is create a vector for the row and a vector for the column. So here you can see we're asking for row 2, row 3, column 3, column 4. And that's what we get. Row 2, if you look at the original My Matrix, and row 3, and then look at column 3 and 4, that's this little 2 by 2 matrix over here with the elements 2719, 2110. We can select an entire row or column by using a comma and then leaving blank. If we want to select all the columns, we leave it blank after the comma. If we want to select all the rows, we leave the rows out. So in this first subsetting function, I'm asking for my matrix, second row, all the columns, because I don't list any of the columns after the column. So there's the second row, all columns. In this one, I'm asking for all the rows, but the third column. And there it is. Just like in a vector, you can leave out with the unary operator the negative, you can do the same thing when we're dealing with a matrix. So look at what this says. This says, I do not want row 1, so it will give us the other two rows, and I want all the columns. So here we're getting the original My Matrix rows 2 and 3 and all the columns. Look at this one. Can you determine what this is going to do? All the rows, yes, because there's no row listed before the comma. And leave out columns 2 and 4. So this is going to give us all rows, columns 1 and 3. If you subset with only one index, the matrix will be treated like a vector that is entered column by column, which you remember is the default when you enter data using the matrix. So here, if we look at my matrix, this 22, Let's get it back up here again in its entirety and try that again. Here's my matrix. So if I want my matrix 2, that's the second element if we go down column by column. If I ask for my matrix 4, that's the fourth element if we go column by column. So 15, 22, 25, there's the 9. Logical vectors can be used to subset a matrix. So here I'm going to have a logical vector, and I have, notice, a comma in here, so everything in front of that comma is for rows, everything after that comma is for columns. So I want the first and second rows, and I want the first and second columns. There's the first, second rows, first, second columns. Now, if you're wondering, why would I ever do it like that instead of numbers? Think about it a moment. Think about when we were working with vectors and we extract it with true and false. We typically are not going to use true and false directly, but rather we're going to be using Boolean operators to develop true and false conditions. For example, suppose you wanted all the even rows. You could do that by establishing a Boolean condition using the modulus operator and then extract all the even numbered rows. You can mix logical elements and integers. So here I'm going to obtain the first and third rows and the first and second columns. Now let's get really fancy. I'm going to get the first and third rows and every column but the second one. If the rows and or columns of a matrix are named, we can use those to subset. So let's name the columns. Here's my matrix, A, B, C, D. Now I'm going to ask for all the rows, columns A and C. Here is row 3, columns C and D. So to review, when subsetting with a matrix, you can get a single element by row number and column number. You can get an entire row or column by leaving off one dimension. You can leave out values, that is, rows or columns, with a negative sign. You can use logicals. You can use names.